So welcome to Star Academia, guys. My name is Brian, and we are here today to proceed with our third lesson. I hope you've watched the illustration and the introduction lesson where I defined what a function is and how exactly we can able to solve functions in Calculus 1. So today I'm going to talk about limits and some of the techniques that are used in solving limits, or we say evaluating limits. So limits are usually evaluated, they are not solved. Now, before I talk anything, before I say anything, I'm going to first of all give you a definition of what is a limit. All right. So the limit, even just like the name suggests, that it is you are limiting something towards a particular value. All right. But the definition of a limit will be definitely something like how a function behaves as it approaches or near a certain point, right? But not exactly at that point. All right, so how exactly is this function behaving when you approach a specific point? And by definition, a limit is written as lim. That's how it's usually, whatever, it's usually shortened, yeah? Lim as x approaches a. It can be maybe x, y, whatever variable. Then a here is a constant value, or whatever thing that is here, okay? Over function f of x, all right, is equals to L. Okay, so then this is the limit. Okay, so how we read this, we read it as limit as x approaches a. So that arrow means as something approaches, so it's approaching. All right, it is not the same as equal. Okay, so it's approaching. I hope you're together. So the way we read this is limit as x approaches a of the function f of x, okay, is equals to L. So then what exactly does this mean? This means as limit as x approaches a, and then of course this, we say this is our function, and then L, this is the behavior of that function, okay, when the input x approaches this value of a. Right, together. So there's nothing complicated in limits. Okay. Now, before I even proceed, let me just give you an example, a basic example of a limit. So you can have something like limit as x approaches 2 over x squared. Okay, so this is a limit is equals to. Now, if you want to evaluate this limit, basically what you're going to do is you're going to substitute the value of 2 in x. Okay, you're going to substitute the value of 2 in x. So you're going to have that this is x, it is going to be 2 squared, which is going to be 4. All right. So even you guys, as new as we are to this section of limits, we can able to evaluate a limit through this process known as direct substitution. So it's direct substitution because you just put the value inside there. So you can also evaluate something like limit as y approaches 6 y cubed plus 10y squared. What do we get here? We are going to get 6 cubed plus 10 6 squared, isn't it? So here we are going to get 6 raised to power 3. It's 36 times 6. All right, so 6, 3, 18, 21, 216 plus 360, 6, 7, 576. So something of that kind. All right. So basically this method is known as direct what? Direct substitution. Okay. So with this method of direct substitution, then we are able to evaluate limits. So what it means is that as this x squared is approaching 2, then the value of x of this function x squared is nearing 4. Okay? Yeah, that is what it means. Is nearing what? Is nearing 4. All right, so it can be maybe 1.9999999, and the value here will be 3.9999999, something of that kind. That is the layman's interpretation of that of what it means for the limit. All right. Now, um, we have things known as left-handed limits, one-sided limits. Let me just write here one-sided limits, and I'm going to explain to you one-sided limits. One-sided limits, these ones can either be left-sided or they can be right-sided.